Hi folks, hope you're all well. This is a video on vascular shunt, which is, as you can see from the title, a combination of two processes, vasodilation and vasoconstriction. What I would say is, sometimes questions talk about vascular shunt in the exam, they mention vascular shunt. However, more often than not, they will talk about, or the question will say something like this. They will talk about the redistribution of blood. How is blood redistributed during exercise, or what is the redistribution of blood during exercise? You'll read different textbooks and things like that, and you'll hear different things. Average human being has 8 pints of blood in their system, around about 5 litres of blood, okay, in your body. Now, when you exercise, the demand for oxygen increases and the blood carries the oxygen. So there are going to be some parts of your body that are demanding more oxygen, therefore need more blood. And that likewise, there are going to be other parts of your body that therefore have to make do with less blood and less oxygen. You can't ever cut a blood supply off, because that structure, that tissue, that muscle, that organ is then in very real danger. So what we're talking about here is, how do we change our blood flow to different parts of the body during exercise so that we stay alive, but we also increase our performance? And this is where these two terms, vasodilation and vasoconstriction, come in. So let's have a look at each of these. First of all, let's introduce a key bit of terminology here. The opening in a blood vessel is called the lumen. Okay, so that is called the lumen. L-U-M-E-N. The opening is called the lumen, not the wall. I know that's ridiculous. I've just drawn an arrow pointing there. I'm talking about the thing that I've just drawn with the white arrow. That is the lumen. So during vasodilation, what can we say? The lumen widens. As you can see in this blood vessel here, that lumen has got wider. The lumen widens. What is that going to do? That is going to increase blood flow, which in turn is going to increase oxygen delivery. Okay? One key point I should have said right at the start, I apologise for not doing that. What we are talking about here are arterioles. The only blood vessels that really vasodilate and vasoconstrict are arterioles, so like smaller arteries. Why? Just think about that for a second. It's total common sense. What do I want to do during exercise? I want to either increase or decrease blood flow to a certain area. It's arteries and arterioles that carry blood from the heart to the muscles, to the organs. There's no point in vasodilating or vasoconstricting in the veins, because that blood's already been sent to the muscles. So what we're talking about here is, how do we increase oxygen delivery to the muscles, to the organs, or decrease it if we need to during exercise? And the only blood vessels that are carrying blood towards those structures are arteries or arterioles. Okay? So vasodilation, the lumen widens, we have an increased blood flow and increased oxygen delivery. During vasoconstriction, the lumen narrows. As you can see in the diagram, the lumen has got narrower, that decreases blood flow, and that decreases, oxygen delivery. Okay? So that's what we do as part of vascular shunt. We vasodilate and we vasoconstrict. So let's get to it then. During exercise, where am I going to vasodilate and where am I going to vasoconstrict? Total common sense here. Where am I going to increase blood flow and oxygen delivery? I'm going to increase blood flow and oxygen delivery to the working muscles, because they need more oxygen. They're the ones that are active. They're the ones that are producing the energy. But equally, I'm also going to vasodilate to the skin. Why? Well, what colour do you go when you're exercising? You go a reddish colour. Why is that? Because I'm trying to lose heat. That blood, as well as carrying oxygen and glucose and proteins and fats and things like that, is also carrying heat. So when I'm exercising and my body temperature is getting very, very warm and it's rising, I need to get rid of that heat somehow. How's the best way of doing it? Get the blood to flow close to the skin surface So I can lose the heat into the environment through sweating and processes such as that. So during exercise, there are two key locations I'm going to vasodilate to: the working muscles and the skin. So where am I going to vasoconstrict to? Well, I'm going to vasoconstrict to the non-working muscles. For example, if I got you in the gym and said, right, I want you to do some leg press exercises, I want you to, some exercises where you're working the quadriceps, the hamstrings, you put your feet on the plate and you push the weight away from your body, you will experience vasodilation to the quadriceps, to the hamstrings, to the gluteals, to the gastrocnemiae. But what you will then have is vasoconstriction to the pectorals, to the latissimus dorsi, to the deltoids, to the trapezii, because they're not working. Their demand for oxygen is less than the muscles in the legs. So you reduce blood flow to them so you can increase it to the working muscles. So where else will I vasoconstrict to? Things like, oops, left the laser pointer on. Things like the gut, intestines, I'll just put it abbreviation, things like that, i.e. your digestive system. Organs such as liver, kidneys, massively important structures in your bodies. Okay? However, during exercise, your body makes a decision and it says, look, the working muscles need more oxygen, they need more blood, so we will have to reduce blood flow to other areas. We can't just manufacture another pint of blood on the spot. So we're going to reduce blood flow to other structures, and we'll just give the liver, the kidneys, the guts, the intestines, just enough blood to keep them alive so that we can give more blood to the working muscles. It's never going to put you in danger, but that's the decision that your body makes, okay? So let's have a look at a typical question on this topic. Now here's how these questions appear. So let's have a look through it. Table 1 shows the redistribution of blood, and remember that's that keyword. So already when I read redistribution of blood, I'm already thinking, right, vascular shunt, vasodilation, vasoconstriction. Okay, now if you look at this table, what we can see is your skeletal muscles, i.e. your muscles, here's your values at rest, here's your values during maximum effort, i.e. exercise. Look at that to that, i.e. a massive increase in blood flow to the working muscles, okay? Look what's happened at the skin, an increase in blood flow to the skin during exercise, but look at the kidneys, reduced blood flow. Look at the liver and gut, reduced blood flow. The brain's interesting. That's staying the same. We're going to tackle that in a second. The coronary vessels, for those of you wondering what they are, coronary blood vessels are the blood vessels that provide your heart tissue with a blood supply. I'm not talking about your aortas or your vena cavas or anything like that. The actual blood vessels that provide your heart muscle with its own supply of oxygen. Remember, the heart is a muscle. It needs oxygen to produce energy to contract. Obviously, as you'd expect, because the heart is beating more during exercise, it needs to increase its own blood supply. So you will also, maybe should have put it on the last slide, but you will also vasodilate to your heart when you are exercising because your heart needs its own blood supply to increase. I'm just going to scroll down ever so slightly. Oops, it is. Just going to scroll down a bit so we can see that this question is explain how redistribution of blood occurs during exercise, and it's a 3 marker. So where are we getting our 3 markers from? Well, as you'd expect with everything in the body, as when we've looked at the heart and when we look at the lungs as well, when do things change in the body? They change when one key thing occurs. So we will have a redistribution of blood when there is an increase in CO2 levels. And this is caused by this process that we know as vascular shunt. And what we can then do is break that term down. So vasodilation occurs to increase blood flow. And finally, vasoconstriction occurs to decrease blood flow. I can get away with that. I don't have to say where I'm vasodilating and where I'm vasoconstricting to in this question because it hasn't asked me to. It's just basically said, explain how the redistribution of blood occurs during exercise. I will get a mark for saying that. that it, as most things are, created by an increase in CO2 levels. I may get a mark for saying that it's caused by vascular shunt, but I'm definitely getting marks for saying about vasodilation and vasoconstriction, and there is my 3 out of 3 for that question. Now, if we look at the next part of the question, and I've just left it on just enough so you can still see it. I said earlier on, blood flow to the... Remember, this is a column that's at rest. This is during exercise. And look, blood flow to the brain has remained exactly the same. And here's the question, look. Explain why blood flow to the brain remains the same during rest and during maximum effort. Right, I bet all of you watching this have had head rush or head spin or whatever you want to call it, when you've stood up too quickly and you've immediately... your vision's gone fuzzy, you've gone dizzy, and you've got wobbly legs, maybe you've even gone down as a result of it. That is when you have momentarily starved your brain of blood and oxygen for a split second, and it's led to all that confusion and loss of coordination and loss of balance. That is why we cannot increase or decrease blood flow to the brain during exercise. It's got to remain the same. Otherwise, several things happen that we don't want to happen. It's a 2-mark question, so what do we need to put for this? Right, firstly, quite simply, for 1 mark, our brain function needs to be maintained. I need to be able to think and coordinate and balance just as well during exercise as what I can at rest. More so, in fact, but that's not why, blood flow just needs to stay the same in order to do that, okay? And finally, for my 2nd mark, the brain requires or needs a constant supply of oxygen. Like I said, when you've got room spin, you have momentarily reduced your oxygen flow to the brain, and it's led to all that loss of coordination, loss of balance, fuzzy vision, things like that. So we need to be saying that the brain function needs to be maintained during exercise and that the brain needs a constant supply of oxygen. And that's how I pick up my 2 marks on that question there. Finally then, this was quite a big question worth a lot of marks on vascular shunt this particular year. Not saying it couldn't come up again, it definitely could. There could have variations on this. This one here, this final question, look, using table 1, explain why performers should not eat immediately before exercise, okay? If we scroll back, okay, come back this way, what are the things in this column, whoops, daisy, what are the things in this column that are associated with eating? Well, it's things like the kidneys, the liver and the gut. They're my digestive organs, things like that. Now, what we need to see is vasoconstriction, a reduction in blood flow during exercise to the kidneys, and a reduction during the liver and gut. That's what we want to happen. We don't want anything else. So coming back to this question, explain why performers should not eat immediately before exercise. If you eat, that food has to be digested. There is nothing you can do about that. You have to digest food that is in your stomach. So very simply, during exercise, less blood needs to go to the gut and kidneys. Simple as that. Because we need that blood to go elsewhere. However, more blood is needed for digestion. So basically what we're saying is we want vasoconstriction to occur to the liver and the gut and the kidneys. But what we're actually doing by eating so close to training or a competition is we're forcing vasodilation there to help digest the food. We want the food to digest. It can't stay there. It'll go off. It'll make us ill. So we want vasoconstriction, but we're actually forcing vasodilation. Ultimately, this means there is now less blood available for the working muscles, so your performance is going to be compromised. It's as simple as that. So I wonder how many of you out there do that. How many of you out there, before you go to training, eat bacon sandwich, chip butty, or have your tea less than an hour before you train? You are actually reducing the quality of your performance by doing that. What you need to do is eat at least 2 hours before you train. You should train and compete on an empty stomach. Why? Because once your stomach is empty, it shows that all of the food has been digested. All of the carbohydrate, all of the pasta has been broken down into glucose and glycogen, ready for you to use. All of that steak has been broken down into protein, ready for your body to use. Whilst it's in your stomach, it's not helping you out. It's making your performance worse. So, that's maybe something that you can apply. So really, really quickly, I'd get it's a 2-marker, but I'd get a mark for that. I'd get a separate mark for that and a separate mark for that. So I've made 3 points. I've definitely got my 2 marks. Okay? So that is vascular shunt, the redistribution of blood, and how we would tackle the questions on that.